Okay, in the last video I introduced NumPy and we actually declared a NumPy array using a list as well as a tuple. In this particular video we will be seeing some of the properties of the NumPy array variable, or sometimes called the object, that variable. So there are several properties, but I will discuss, for example, last time I discussed one property which is dtype, a.dtype, and that actually stores the information of the data type of the elements of the array, of NP array. Remember, NP array, all the elements of NP array, they must have same data type. It cannot store heterogeneous arrays as it is. Okay, now there is another property sometimes called the dimensions, or ndim. That tells actually what are the dimensions of the array. I need to explain this term dimensions with the following example. Let's say, for example, that's an array. Just consider that's a list, for example. 1, 2, 3, that's one list. And if it is an array, for example, if this is np dot array, with that list, we will say that array as a one-dimensional array because we only need one index to access that. For example, if you need to access any element in this array, you only need one index, either 0, 1, or 2, only one index. That's okay. So in this case, we have just one-dimensional array. On the other hand, for example, if you see here, that's one array or one list, that's another array, another list, and that's another list that contains lists inside. For example, let's say that's array 1 and that's array 2, and that is simply an array of two different arrays. That's an array and that's an array. For example, A1 is this array and A2 is this array. Now, if we need to access any element in this particular array, we need two indices. First of all, we have to locate whether we are going to talk about A1 or A2. We need one index for that. For example, if we want to locate A1, that means we are going to access with element 0. Let's say this whole array is A. So first of all, we say okay. 0 means we are going to access from A1 and A2 one of those. So 0 means the first one. Okay, now A1. Now inside A1, which element? This is the 0th element, this is the first element, this is the second element. Let's say we want to access the first element. So that means we are going to talk about, this. So very loosely speaking, the total number of indices that are required to access an element inside the array is called dimension of the array. And ndim that actually defines that actually describes this property, the total number of dimensions. Consider, for example, this is a 2D array or two-dimensional array. Let's say that's a two-dimensional array A1, and that's another two-dimensional array A2, that's another two-dimensional array A3, for example. And let's say this is an array of two-dimensional arrays. Let's say np dot array. Now that whole array, whatever that array is, a three-dimensional array, and the reason is to access any element we need three indices. First index will define which one of these we are selecting. For example, let's say we are selecting that, so one index is needed, that index is 1, for example. Then inside this structure, like so, we need two more indices to locate a particular index. For example, because A2 is a two-dimensional array, it has two one-dimensional arrays. So which one-dimensional array you are, it has many one-dimensional arrays. So which one-dimensional array you want to pick? Let's say the sixth one with index 5. Now you have located the sixth array. Now in that array, what element? Let's say the 8th element. So we need three indices to access a particular element. So the dimensions of this array is 3. So let's play with that in Jupyter Notebook just to get more comfortable with the term dimensions. So let's say, for example, we have an array A. Let's say A is np dot array and let's say it contains a list, let's say 1 2 3, and then we have another array, one-dimensional array, let's say 4 5 and 6. That's another array, and that is an array of these two arrays. So that is basically a two-dimensional array. It is array of arrays, list of lists equivalently. So that's A, for example. Oh, what's the problem? Oh, we haven't imported NumPy. We should have. So import NumPy as NP. Okay, we need not to import that every time. Actually, I'm recording this video after a few hours, and I have restarted all these things, so I have to import now for the first time. But once imported in the notebook, as long as the notebook is running, you need not to re-import anything. Okay, so a dot, for example, ndim, a dot ndim. So that is 2 here because there are 2 dimensions. For example, if I want to access element number 3, this element, so this element is located in the first array of the 2 arrays, which has, so the first array, there are 2 arrays with index 0 or 1, so I am going to look into the first array, which is 1 2 3, and in that array I'm going to look for the element number 2, element with index 2. So that's how you can access the elements of multi-dimensional arrays, or arrays with more kind of dimensions. Let's say we have another array, just to get more familiar with, np array, let's say, and we have a list, and that list actually contains that list actually contains 3 one-dimensional arrays. Not only that, actually, I'm confusing you a lot. Let me just, let's say we have 1 2 3, let's say we have 3 one-dimensional arrays. Let's say we have another 2 4 5 9. The sizes of arrays maybe different. Yeah, is that true? Maybe different? Yes or no? Let's see. For example, the first array has size 3, and the second array has total size. Is that okay? I guess yes. And now if you want to access, for example, an element of an element with let's say I want to access this element 5, so that is in the second array indexed with 1, and then in that array it has index 2. So I've accessed this element. Oh, why not? Too many indices for an array. Why? Why is that? Why too many indices for an array? B. So let's say b dot ndims, and then that is 1. Why one-dimensional? I have I have this one-dimensional array, and this is another one-dimensional array, and I have made a list out of it. I mean, this is 1D array and another 1D array. I've concatenated them together, so I should have accessed this element. The problem is, when you are going to define multi-dimensional arrays, the number of elements for each dimension, they should stay consistent. For example, if the first array has 3 elements, the second array must have 3 elements. Or if the second array has 4 elements, then the first must have 4 elements. If that is not the case, the array will not be defined like a multi-dimensional array. For example, if we, for example, extend our first array with, let's say, -1, now B will be having 2 dimensions, no problem. And now we will be able to access, for example, this element 5 like so. So we will go to B again. We will say, okay, select array number 2, and in that array, select the value indexed by 2, which is 5. So accessed, no problem. And that stays true if you're going to define, for example, a 3-dimensional array. Let me just give you an example of 3-dimensional array. Let's say C equals np dot array, and let's say we have 1 2 and 3, And then we have another array, for example, 4, 5, 6. Remember, so let's say we can have one more. For example, we can have one more list. Why not? So let's say we have 0, 0, -1, let's say, and that is a two-dimensional array. Yeah, that's a two-dimensional array. Great. Let's say we have another two-dimensional array. Let's say we have another two-dimensional array with same kind of consistency, the number of elements and stuff. Let's say these elements are all minus of the other ones. Let's say this minus, 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 and this is +1. And now we have this. If you see this thing, that's a 2D array. That's a two-dimensional array. That is also a two-dimensional array. An array of two-dimensional arrays is basically a three-dimensional array. Now that's a three-dimensional array. This one. See. So if you we have some. I should have defined this with commas rather than spaces. Actually, yeah. The reason I did that is MATLAB. I worked in MATLAB also. So MATLAB allows this space separated list, but I just confused the things with Python as well. But Python requires comma there. Okay. With MATLAB, by the way, just as a side note, MATLAB allows you to have commas as well as spaces, but this Python just restricts everything to comma. That's great. Okay. That is C. So now if you check C.endem, that is 3. If you, for example, want to access this particular element, what should you do? First of all, you select the one of the 2D arrays. There are two 2D arrays. So this is the first 2D array, and that's the second 2D array. And if you, for example, want to access this particular element, which is -3, if you want to access that, you first have to access one of the two-dimensional arrays. So let's say I access the second one with the index 1. Now you are in this particular 2D array. In that array, which 1D array you are talking about? So I'm talking about the very first 1D array. So the very first 1D array is indexed by 0. And in that 1D array, which element you are talking about? So I'm talking about this element that has index 2 in this particular array. So now if you press enter, you will get -3. Wow. So that is basically how, and by the way, you can make a 4-dimensional array. A 4-dimensional array will be an array of 3-dimensional arrays, and so on. You can make, for example, n-dimensional arrays, and that's one reason why we call this as ND array, n-dimensional array. The type of C is ND array, n-dimensional array. You can add as many dimensions as you want. Great. We will continue exploring this NumPy more and more in the upcoming videos. In particular, I will talk about this shape property of this NumPy. We have already discussed D-type. We have discussed endem. In the next video, we will talk about shape, and we will discuss more about the NumPy. So hope to see you in the next video.